Hello everyone, welcome to Sucharit Search classes. Students, in our today's video, I shall cover up the complete chapter Arithmetic Progressions. I shall try my level best to make you all understand the concept of the chapter, and also we will solve the questions given in the NCERT textbook, and then we will solve some probable questions for the upcoming board examination. Okay? Alright. One thing, before I start the chapter, I would like to request you all to subscribe my YouTube channel and please like and share my Facebook page Sucharit Search Classes. I think my Facebook page and the YouTube channel will make you all benefited. Okay students, so let's begin with our chapter Arithmetic Progressions. First of all, let us study a few of the collection of numbers. Suppose the collections are 1, 2, 3, 4 and the collection is continuing. Then another one is suppose 2, 4, 6, 8 and it is continuing. Then next one is suppose 1, 4, 7, 10 and it is also continuing. Another collection, let us write 1, 4, 9, 16, 25. In that way these collections are continuing. Now here all these collections what we have written, for writing these collections we have followed some criteria, we have maintained some rule, is not it? So in the first case, the first collection, the second succeeding term we have written by adding 1 with the preceding term. Same way in the second case, succeeding term we have got by adding 2 with the preceding term. Same way the third one, with the succeeding term we have added, with the preceding term we have added 3 to get the succeeding term. But in the fourth case we have not got by adding some numbers with the preceding term. We got this collection by doing the square of the natural numbers. Natural numbers are what? 1, 2, 3, 4, 5. So 1 square gave 1 the first term, 2 square gave 4 the second term, 3 square gave 9 the third term, 4 square gave 16 the fourth term. In that way the series this collection is written. Okay. Now all these 4 collections are following some pattern. So when the collection will follow some pattern, that means we can identify a general rule for writing this collection. So when the collection will follow some pattern, then this collection of numbers are considered as a sequence. Got it? So sequence is what? When the collection of numbers will form a pattern, then this collection of numbers are considered to be a sequence. Now suppose a sequence is given, and in the sequence, if we suppose the second case we are considering this one, in this sequence what we got, the second term we got by adding 2 with the first term. Okay, third term we got by adding 2 with the second one. Same way third term also we got by adding 2 with the fourth term we got by adding 2 with the third term. Correct or not? In that way every term of the sequence we got by adding a fixed number with the preceding term. Correct? So when we will get the succeeding number by adding a fixed number with the preceding term, then this kind of sequences are considered to form an AP or the arithmetic progression. So arithmetic progression is what? Arithmetic progression is, we can say that it is a collection of numbers. Now how the collection of numbers to be written? Collection of numbers, it should be collection of numbers or list of numbers where each term is obtained. Each term we have got, how we have got? By adding a fixed number with the preceding term excluding the first term. First term we have not followed any rule, is not it? So this type of collection of numbers or the sequence are considered to be an AP or the arithmetic progression. Some more examples let us see, or let us write to which are forming an AP. Suppose we have an AP, suppose 25 the first term, the next term is, say, suppose 30, then 35, then suppose 40. Okay, so each of the terms we are getting how? By adding 5 with the preceding term. So this is also an AP, correct? Now suppose another one is there, say 10, then next term is minus 5. Okay, then next term is 0. Sorry, 10, then next term is 5, and then next term is 0, then next term is suppose minus 5, then minus 10. In that way it is continuing. So here if we see, in the first case what we have written, we have written added 5 with this term to get the next term. But here if the difference is 5, same 5 only, but what we have added to get the second term, 10 plus minus 5 we have added. Okay, so here each of the terms we are getting by adding minus 5 with the preceding term, correct or not? So this is also forming an AP, correct? Now now let us consider an AP. Suppose it is this third one I am taking, 1, 4, 7, 10, and it is continuing. So in this AP, if we get the difference of the individual terms, then 4 minus 1, that is equal to 3. And this 4 minus 1, this can be represented as, if we write, suppose this number 1, that is first term, if we write either, or if we represent by A1, second term if we represent by A2, third term if we represent by A3, fourth one if we represent by A4, then this 4 minus 1, that means 4 was our second term, that means it can be written as A2 minus A1, correct or not? Same way, the difference of the next two terms, that means 7 minus 4, that is also equal to 3, and this 7 minus 4 can be represented as A3 minus A2, correct? And the third difference, that is 10 minus 7, that is also equal to 3, and it can be represented as A4 minus A3, correct or not? Now in each of these cases what we saw, that the difference is giving us a constant number, correct? And that constant number is definitely 3. So if the difference of each of the individual terms, that is A2 minus A1 or A3 minus A2 or A4 minus A3 or A5 minus A4, whatever, if it is giving us a constant number or a fixed number, then this difference is known as the common difference, got it? And this common difference, if we represent by the small letter d, then d can be written as equal to A2 minus A1, which also equal to A3 minus A2, which also is equal to A4 minus A3, and so on, correct or not? So this d is what? It is the common difference, and that common difference will be, the term will be applicable only if the sequence is forming an AP or arithmetic progression, got it? Now in this AP, the first term, that is A1 is our 1, okay? Second term is A2, and A2 is given 4, alright? Now this A2 can be written as, or 4 can be written as 1 plus 1 into 3, Okay, this one is what? This one is the first term. Okay, first term can also be represented as a1 or a. So we can write it equal to a plus 1 into this 3, it is the common difference, that is d. So a plus 1 into d, which is nothing but equal to a plus d. Got it? Same way, a3, that is given 7, and it can be written in the form 1 plus 2 into 3. 2 into 3 gave us 6. 6 plus 1 is equal to 7. So it can be written as, this 1 can be represented as a plus this 2 is cannot be written anything, so 2 will remain 2 only, and this 3 is our d. So a plus 2 into d, so it can be written as simply a plus d. A plus 2d. Okay. Then next term a4, that is equal to 10 given. So it can be written as 1 plus 3 into 3. 3 into 3 is 9. 9 plus 1 is 10. So it can be written as a plus 3 into d, which is simply a plus 3d. In that way, if we continue, then a5 if we write, which you don't have in the given series, number is not shown, just it is there, but number is not shown. So a5 if we write, now you see the pattern. Here, when it is a2, then it is a plus d. When it is a3, then it is a plus 2d, one less. So when it is a1 or a, then it will be taking the form a plus 0 into d. Correct or not? 0 into d will be actually 0, and here only it is a, so it is equal to a. So a5 if we write in this pattern, so a plus 0 into d, first term, second term is a plus d, third term is a plus 2d, fourth term is a plus 3d. So fifth term will be what? A plus 4d. Am I right? So in that way, the terms will be continuing. And if we now generalize, then each of these terms can be represented as, or we can say that the general form of the AP is what? The general form of the AP is, the first term is represented by what? A. So first term is a. Then second term is represented by, here we got second term is a plus d. So we will have the second term a plus d. Next third term is a plus 2d. So next term will be a plus 2d. Then next term is a plus 3d. So next one will be our a plus 3d, and in that way the AP will be continuing. So this a plus d, a plus 2d, a plus 3d, this is the general form of the arithmetic progression. That means each of the terms can be represented in terms of their common difference. First term if it is a, then with a, if we add the common difference, then with the first term if we add the common difference, then we will get the second term, and with the first term if we add the twice of the common difference, we will get the third term. With the first term if we add the thrice of the common difference, we will get the next term, and in that way the AP will be continuing. So the arithmetic general form of the arithmetic progression is this one, a plus d, a plus 2d, a plus 3d, and so on. Now see, you are finding some changes in the board. These changes are made only for saving time. Okay, now you see, this is the general form of the AP. Now the first term, that is a1, it can be written as a. Okay, second term is our a2, which we have written as a plus d. Third term is a3, which we have written as a plus twice d. Okay, then next term is a4, that we have written as a plus 3d, and in that way we have continued. Now this, what we have written a plus d, a plus 2d, this also we will represent in terms of another pattern. Now see this second term, that is a plus d. This a plus d, we will write in terms of the term, number of term. So it can be written as a plus, here the number of term is what? It is the second term. So it can be written as 2 minus 1, which will represent 1, and d. So a plus d can be written as 2 minus 1, that is 1 into d. correct or not? Same way, this third term, it can be also written as a plus, in terms of number of term, it is third term, so 3 minus 1 into d. Okay, same way, this a4 can be written as a plus 4 minus 1 into d, correct? So this pattern if we follow, then the first term can be written as a plus 1 minus 1 into d. Okay, now you see a1 is that is the a is written as a plus 1 minus 1 into d, a2 is written a plus 2 minus 1 into d, a3 is written a plus 3 minus 1 into d, a4 is written a plus 4 minus 1 into d. In that way, if we continue and if we have a term which is nth term, then this an can be represented as a plus n minus 1 into d. Got it? And this an is equal to a plus n minus 1 into d. This is called the formula for finding the nth term of an arithmetic progression or AP. Okay, and in this formula, an is the nth term. Remember this points. That is what individually what each of these letters are denoting. So an is nth term. This a, this is the first term. Okay, this n is representing number of terms. Okay, and 1 is a fixed number, so it's not required, and d is the common difference. Okay, so meaning of each of these representation has to be identified properly and remembered also. So an and formula for finding nth term is what? An is equal to a plus n minus 1 into d, where an is representing nth term, a is representing the first term, n is representing the number of terms, remember. Okay, and d is representing the common difference. Okay students, so let us restrict ourselves up to this and let's try to recall what we have learned so far. So first of all, we have developed the concept of the sequence. So sequence is what? It is the pattern of numbers. Got it? Then we have learned what is the arithmetic progression. So arithmetic progression is what? If there is a sequence and there is a list of number, and in this list of number every succeeding term if we obtain by adding a fixed number with its preceding term, then that is called an arithmetic progression. But first term will not be applicable in that case. We can say that except the first term. Okay, every succeeding term is obtained by adding a fixed number with its preceding term except the first term. Correct? After that, we have developed the concept of the general form of an AP, and in the general form we saw that it is given by a plus d, a plus 2d, a plus 3d, and so on, where a is the first term of the arithmetic progression or AP, a plus d is the second term, a plus 2d is the third term, a plus 3d is the fourth term, and so on. Correct? Then we have seen the formula for calculating the nth term of an AP, and there we saw that nth term is given by an, and the formula goes like this: an is equal to a plus n minus 1 into d. Okay, where an we know what is n. N is the nth term of the AP, and n is what? N is, remember, it is the number of terms. Normally students misconcept in these two parts of the formula, an and n. An, remember, it is the nth term, and n, remember, it is the number of terms. And a and d other parts what we have, a we know it is the first term of the AP, and d is the common difference of the AP. Okay, so this much we have learned so far, and based on this concept we are given some two exercises in the NCERT textbook. So we will try to solve these two exercises. I will try my level best to make you satisfying in solving the questions given in the exercises, and I will also try to solve most of the questions given in the NCERT textbook. Okay.